Welcome back to MSK's tutorial on MIL and SIL. In part 4 of this tutorial, we'll be covering the software in the loop, or SIL configuration. The goal of this section is to convert the controller subsystem into an S function with auto-generated C code. Here we'll be using the simple SL controller. So how do you create an S function? Simply right-click on the controller and go to the Real-Time Workshop and select Generate S Function. This will bring up a new dialog shown on the left where you can click Build. So is that all there is to it? Well, no, not really. Remember, we eventually want to run this as a hardware-in-the-loop system. That means we have to run it in a real-time platform and therefore need to select a fixed-step solver. First, we go to the Simulation menu and select Configuration Parameters. We then select Fixed Step from the type and select the ODE3 solver. Now note, this won't run as is. There is a potential gotcha that we'll cover later in this tutorial. Once we've selected our fixed step solver, we can now build the S function and open it in Simulink. So again, we right-click on the controller subsystem, go to Real-Time Workshop, and select Generate S Function. This will open the new model once you click Build. Now that the model's been built, we have to bring it into our library. So copy the model that was just created, and then go to your original model, right-click on the controller, and select Link Options, Go to Library block. Now we're going to modify the library to allow it to use that new model. First, go to the Edit menu and select Unlock Library. You can now edit the library. You can paste in the model that we created with the Generate S function, and then double-click it to rename it if you'd like. Now that the model exists in the library, we have to make it selectable as a choice. Next, double-click the green box at the top of the library. This will open up another configuration dialog. Here, make sure you check the new model that you just added to the library. Then you can click OK and save the library. Back in the main model, we can now right-click on the controller subsystem and select the S function that we just generated. This will allow us to simulate the model using that S function. We've now run SIL. Now, let's take a look at some of those potential gotchas that may have caused problems for you. First, if you tried to run the model with a fixed step solver, you may see this error here. It's complaining about rate transition blocks that need to be inserted into the triggered subsystems. The power window model includes 2 triggered subsystems, so we must insert rate transition blocks for each of them. The first one is in the main controller logic subsystem, so we open the Simulink library browser and drag in rate transition blocks for each of the inputs. The second triggered subsystem exists in the controller top level right before the obstacle detection. If we insert a rate transition block here, that should get rid of that error. Another error you may encounter when generating the S function has to do with undefined functions or variables. In this case, there were some variables we defined from the workspace that may not have been in existence when you tried to generate the S function. Therefore, run that script to define those variables and try to generate the S function again. We've now successfully generated C code in the form of an S function. Lastly, we'll take a look at hardware in the loop, or HIL, and give a brief review of what we've learned. For more information, come check out our website at the address listed below.